Hello, everyone, and welcome to APS webinars. Before we get started, I want to remind you all that if you want to hear about other APS webinars, to please sign up for our mailing list. You can sign up by visiting the URL that is visible on your screen, www.aps.org/careers/guidance/webinars. The title of today's presentation is Physics Learning Above and Beyond the Usual. I'm Crystal Bailey, and I'll be your host for today's broadcast. Thank you all so much for joining us. APS webinars are brought to you as a service of the American Physical Society, connecting you with the expertise of individuals who can offer insight into physics careers, educational programs, and professional development for students, working physicists, and educators. Today's webinar is being recorded, and everyone who registered will receive a link to the recording, but please allow 24 hours for the video upload. After our speaker finishes the presentation, the remainder of the program will belong to you for our question and answer session. Because of the number of people attending this webinar, we are only accepting text questions. So if you have questions during the broadcast, please ask them in the questions box located on your screen, and we'll try to get to it at the end of the presentation. Lastly, we encourage you to complete the survey upon exiting so that APS webinars can improve its ability to provide you with these valuable services. And with that, let's get started. Linda Barton, our speaker, received her BS in physics from MIT, where she worked for several years at the Francis Bitter National Magnet Lab, and her PhD in physics from the University of Illinois at Urbana-Champaign, with experimental thesis work on critical phenomena of dilute ferromagnets. Following graduate school, she spent nearly a decade at the research labs of Eastman Kodak in Rochester, New York, where she worked on development of magnetic materials for magnetic recording applications. In 1996, she joined the faculty at Rochester Institute of Technology in the School of Physics and Astronomy. At RIT, Linda has focused her teaching efforts on development of intensive upper-level laboratory training for undergraduate physics majors and implementation of senior capstone research for all physics majors. She maintains a small-scale experimental research effort in novel magnetic materials, staffed solely with undergraduates. With that, Linda, I'll hand it over to you.
Hello, I'm going to talk to you today about pop-up classes. Pop-up classes are one easy way that you can add elements of physics innovation and entrepreneurship to your standard physics curriculum. We are part of the Pipeline Project, which is an APS led effort of 6 schools around the U.S. who are all working on innovation and entrepreneurship additions to physics curricula. Within this, a innovation and entrepreneurship addition could include things like professional skills development, leadership skills, communication, public speaking, collaborations. They could be technological expertise. As my bio indicated, I'm a hopeless experimentalist and lab rat, so for me this means developing hands-on skills, facility with equipment and techniques, and ability to build stuff and get stuff done. You could also include things as private sector concepts, information for undergraduates on intellectual property or business models or how industrial innovation actually works. I consider anything we can do to help our undergraduates get prepared for non-academic jobs in the marketplace, either running their own small companies or becoming part of large corporate research and development efforts, is a good thing. And it's hard to get ways to glue this kind of thing into a traditional physics curriculum where we seem nationally to be hidebound with too many courses in electrodynamics and quantum mechanics and rotational mechanics and this and that. Adding elements of innovation and entrepreneurship can seem like just an impossible hurdle for a standard physics curriculum. So pop-ups are quite a thing out there in the rest of the world outside of physics departments. They're very common in programs in entrepreneurship they're becoming more common in straight up engineering programs. I encourage anyone who's interested in pop-ups to take a look at what other schools are doing. Texas A&M has a just awesome list of things that they're doing, and I will admit I have stolen liberally from some of their ideas of where to take this. I think this is a model that will become more popular over the next few years as various departments and curricula realize the freedom it gives you. So in this talk, I'm going to talk about what's a pop-up, since some of you may have never heard of such a thing. Why would you ever want to do such a crazy thing? And then, of course, how, when, and where, etc. So, what's a pop-up? There's a few characteristics that I think kind of define the beast. First, they're usually short. We're not talking a 3-credit full semester course. 1, 2, 4 sessions maybe, a couple hours. They rely on volunteer faculty. Yes, that means this will not count as part of your normal teaching load, at least as the way people are doing them now. I have done the little bit of pop-ups that we've started here strictly as an add-on because it's fun, on my own time, with my own energy. That's the bad news. The good news is you get volunteer students too. The students are not getting any credit. They don't have to do this. It doesn't show up on their transcript. So the fun part is you get students there because they really want to learn what you're going to be talking about. They are eager and enthusiastic about what's offered, and if they're not, they don't come. I try to set up pop-ups so that there's almost no cost to the student. There's certainly no tuition cost as they're presently constituted. You might have fees for supplies if you're going to be using consumables and don't want to bog down your department with too many small costs. So basically, these things are off the books, under the radar, and completely out of the academic mainstream. That, of course, is both an advantage and a disadvantage, which we can talk about downstream. So why would you do a pop-up? One of the most important parts from my point of view is it allows you as a faculty member to try something new or crazy or different that you haven't figured out a place or a way to stick into a traditional course. It certainly lets you do off the mainstream things that might not fit logically into any of your regular curricular coursework. If you want to do something that maybe half of the old guard in the department won't approve of or wouldn't vote for, and it's okay, it's not required, it's a pop-up, it's just for fun, so you can basically go off and do whatever you want in a pop-up course. On the student side, it lets a student dabble in something, and they don't have to invest a substantial part of their coursework in time and credits towards trying out something that otherwise they might never be willing to commit to. I've had notable success trying to get students who had previously been totally committed to theoretical work to come dabble and try a little fooling around with electronics and hands-on skills. And some of them have gotten really turned on by it and decided it's fun. You also have a very fast turnaround. If you think of something, boom, a week and a half later, you can be offering a pop-up course in it. You don't have to go through curriculum committees. You don't have to write learning outcomes and goals and all of that fun stuff. But I think the primary reason that I do them is they're just fun. It's a great way to engage with students, to do some fun things, and to avoid a lot of the chaos around a university. All of us started teaching because we love teaching, and it's fun to do something that's just absolutely the pure experience of teaching with students. So I'm going to spend some time now on examples of pop-ups that we're doing here at RIT, and I beg your tolerance here in that I only learned about pop-ups less than a year ago and started basically immediately. So some of this is very new. Some of it has been better debugged than others, and I've got hundreds of ideas of other things I want to do. But this right now is our sort of first shot across the bow of doing pop-ups at RIT. Um, to go back to our list of the kinds of broad divisions of things you could do, we've added a whole bunch of things that are professional development short courses or pop-ups. The first one really isn't what you would think of as innovation and entrepreneurship, but it was the first thing I threw together, and it's been very popular, which is discussions on grad schools. Physics seniors want to go to grad school. They have no clue what they're doing. So I get together several faculty and seniors, schedule an hour and a half in a room. We talk about programs, we talk about sources of information, how to use these resources. Students don't even know what to look for when assessing a grad program. You know, what's a big department, what's a small department, how to get an idea of funding scales, etc. They don't have any kind of realistic expectations. You know, gee, I have a 4.0 from RIT. Does that mean I'll get into Princeton? Many of them want very much to talk about non-physics alternatives. And it's been my experience that physics majors are really frightened to ask physics faculty for advice on this. And that's kind of silly because there's great options to go on for a master's degree in materials science or engineering or entrepreneurship or things like that. So these have been very popular. We're now doing grad school discussions probably once or twice a semester. We have career fairs on campus for students seeking co-op positions or summer internships. So before each of those, we offer several pop-ups. First of all, a workshop pair to work on resumes. The first workshop, we talk about what's to put in a resume, how to write a good resume. We bring examples of good resumes. Students, again, don't really know where to start on this. The second session, we encourage them to bring their resume. It could be a draft, it could be very rough, but bring it, and then we all trade and work on them and beat on them to try to get the resumes in better condition for realistic job applications. I typically try to bring job descriptions from several jobs or corporations that are visiting on our career fairs, and then try and target or tailor resumes to match those particular jobs or corporate environments. And students learn how you can kind of shade a resume to be more appropriate for different environments. We also have a really fun workshop on elevator speeches. First, you give them a half an hour discussion of how important it is to be able to give a quick, snappy intro that summarizes who you are and what you do and what you want to do. And then they all go around robin around the room and practice giving this short intro to each other. This is an ideal time for us to introduce some ideas on the importance of networking and meeting people and passing out business cards, how the real world works for getting a job, that it's not just enough to say, I have a bachelor's degree in physics, please hire me. I've also set up mock interviews. These are a great deal of fun. They require a little play acting on the part of a faculty member. One time I actually got another faculty member to play this game. Each of us went and found a half a dozen relevant jobs from monster.com and other current websites. So these were jobs that were up and out there whatever week we were doing the pop-ups. And then the faculty study up that company or that job so that they can pretend they work there. We present to the students these folios of information on the various jobs, and they decide which one interests them and schedule an interview with the faculty member. And then the faculty member, of course, plays recruiter, and I typically give them about a half an hour, and I have a list of, you know, typical recruitment questions to give to the students and help them learn how to answer the kind of things that you're apt to get on a corporate interview for an internship or a permanent position for a terminal bachelor's. It's kind of hard to play it straight as the faculty member when you know the student pretty well and you're sort of improvising on the job, but that's okay. If you've read a little bit about the company and the technology, it's pretty easy to learn to ask fairly insightful questions of the student. I typically give the student about a half an hour, another 15-20 minutes after the interview, where I immediately give them feedback about the mechanics of how they handled the interview. You know, did they make eye contact? Were they direct in their answers? Were they too soft-spoken, etc.? Students who've gone on to our career fairs have said this was extremely helpful, and I certainly think it's a fun thing to do. Dearer to my heart is the second sort of group of things one could do a pop-up about, and that for me is hands-on skills or technological skills. So the most recent pop-up I did was the last day of classes right before Christmas break. I thought it would be fun to have everybody get together and just assemble a little kit for these silly blinky light Christmas trees. Surely on the last day, Friday before Christmas, kids could spare 2 hours to just come do something fun with their hands and build a gizmo. I bought 12 of the kits. I had managed to scare up 6 solder stations from around the department, and we set this up. Holy cow, this class filled instantly, and I had to turn people away. I only had 12 kits, and I will say it turned into total, complete mayhem. Undergraduate physics majors don't know how to solder anymore. They had a lot of difficulty with this kit, and eventually we got most of them to work perfectly and a few of them to sort of work, and it was overall a pretty good success. They certainly had a good time and enjoyed it, and my takeaway from it was, holy cow, we need to do more soldering. The hands-on activity that I've had the most experience with is a short course in Arduinos. I started this when I wanted to learn about Arduinos myself, so I bought one and I started fooling around with it, and I got it working and did some things in my research environment with it for temperature controllers and things like that. And I thought, wow, this would be fun for students to learn something about. So I have now done the Arduino course 3 times. There's one session with an optional follow-up session. Each session is 2 hours. For resourcing on this, I did talk my department out of a couple $100. I bought 6 plastic shoeboxes and put in each of them an Arduino, a very inexpensive proto board, and assorted components, LEDs, buzzers, resistors, transistors, few motors, this, that, and the other. Just a pile of stuff that I thought would be fun to build with. I did borrow from general departmental stores voltmeters, power supplies, and I used a lab that we have here for everybody to use. I limited this class to 12. The students worked in pairs if it filled up, and I had them bring their own laptops and had said to them to please pre-install the IDE, the development environment software that you need to talk to an Arduino. That's easily downloadable and installed. Most, but not all of them, had actually done the installation. I did not require any prior programming experience. Many of the students had never had our mandatory electronics lab that juniors take, so they didn't know anything about protoboards, or they couldn't figure out diode polarities. We had a lot of real beginners on the electronics skills. The upshot of this is instructor is very busy, particularly early on, to get all of the IDEs working and the minimal set of stuff going with kids. I wrote a series of handouts but the goal is that these be kind of guided explorations. I did not want this to be yet another lab manual for advanced lab. I've written dozens of those. This is supposed to be a pop-up. It's supposed to be fun. But since the kids probably don't know any coding and have never seen one of these objects before, I started with a very simple example. Type exactly this code in, build this very simple circuit, one light blinks. Then we started adding. Oh, why don't you try changing the blink sequence? Add another LED. And that was very loosey-goosey instructions so that they could fool with it on their own. My handout is about 8 pages long, and each page is like another cool thing you can build that in a semi-systematic way I've added more and more circuit elements to teach them a little electronics and more code elements so that they could get used to the software. All of it's in the guise of suggestions. It's not, do this and then do this and then do this, like a lab manual might be. And I was trying to develop both the code skills and the hardware familiarity hand in hand in both a systematic way and kind of a fun way. So again, to beat a dead horse here, the code, we started with the absolute minimum to make the thing turn on. And then the next page just kind of happened to introduce if-then-else conditionals. And then the next little cute circuit just happened to introduce loops and loop structures. And then the next page happened to add conditionals where you can give a keyboard input and have a user interact with the device once it's running. And on the hardware side, again, the first page was the easiest of digital outputs. Then we added digital in and out, and then analog out, and then analog in and out. So as they kind of flittered their way through these suggested circuits, they got used to the capacities of both the coding language and the hardware. This was really successful. Within an hour, almost all of them are completely off script, trying all kinds of crazy things. One of my favorite students was one who, the minute we got the buzzer going and he realized that he could control the pitch on an Arduino, the Arduino could control the pitch of the buzzer. He's a musician, and he spent the next hour and a half trying to make his Arduino-controlled piezo buzzer play the tune from Furry Lee's. Believe me, this was not what was in my manuals, but he learned a tremendous amount. He got all the loops and conditionals and everything. He figured out the code just by the little examples I gave and his determination to make his Arduino play Furry Lee's. All of them seem completely blithely unaware of the fact that they're learning to write compiled C, which if you'd told them that up front, they would be afraid to start and dread it. They're just doing it, and they copy the syntax from my little code fragments, and they go to town. Several of them, more than several by now, have gone ahead and are purchased their own Arduinos. I'm getting nudges from various faculty members that they're bringing the Arduino knowledge back into the research labs and taking these skills into their capstone projects and other things. Several of them are putting together a contest that they want to do to build robotic stuff. This is out of my hands now. The students know more than I do about Arduinos. They're off to the races, and that's just wonderful. This was totally new technology for them, and they're off and running. My second session, which is less well attended in general, and definitely an add-on for the Arduinos, was a session on how to handle more power, motors, relays, switching, real wall voltages, etc. My suggestions, if you were to do something like this, and this I think really follows through to any kind of a pop-up, is keep it casual. These students have enough formal things where they have to follow the manual exactly and color in the lines at every step of the way. My lab manual, my suggested handouts are full of handwritten scribbles like this circuit diagram that I grabbed from the second session. Yes, this is what I'm handing out to them. They should learn that you can do electronics from from little notes like this, and you don't need anything fancy, and in fact, fancy stuff scares them off. Keep it loose. I've got a code fragment here where I was trying to introduce if-else statements, but you'll notice what comes in the if is insert your code for whatever you like. Again, I'm trying to get them to think on their own and do something creative and different. And just keep it fun. Open-ended suggestions, snippets of codes. Another hands-on skills program that I've been working on is some basic machine shop. I have groups of 4 because 4 is plenty for me to work with in a metalworking shop. Right now we're just doing basic skills with hand tools, files and tapping, and drill press and bandsaw. I've got some projects in development for a simple training for use of the milling machine, and maybe someday I'll have time enough to develop a good lathe-based project that they could work through. For logistics, to set one of these up, I would suggest definitely make a fun-looking announcement. I snipped just the top of the header here from my little Christmas tree project, and you can see I'm deliberately being silly. I'm trying to make it look like fun. I'm not trying to make this look like another coursework where you got to go study. I have never done anything online to publicize these. I literally hang a half a dozen flyers on the doors to the Ed Lab, on the doors to the student hangout room that we have for physics majors, around the courses rooms that they use typically for their courses. The students will figure it out. It's important that you make sure that your departmental technicians are on board with this. Typically, they do not react well to large groups of students doing particularly laboratory-oriented things after hours at strange times if they're not aware of it. So I've tried very hard to keep our technical staff up to date with what we're doing and help so that they know what's coming and why, and it doesn't catch them broadsides. Whatever sign-up system you use, make sure the students know how. It helps if you can do advanced sign-up. Many of my classes have filled almost immediately. The first class I offered was the Arduino intro, and I sent out a note to just the sophomores that I happened to have in another course, so I had an email list for them, at midnight, and to my absolute shock, within a half an hour, I was half full. So you need to figure out how to have them sign up and make sure they have a way to do it clean, because many classes will fill. I don't think it helps to have a whole lot of advance notice or fuss. It's nice to just kind of play this loose. That's what a pop-up's supposed to be about. Here I've got another fun flyer for my Arduino, just the top of the flyer. Again, I'm trying to make it sound like fun. It's Tinker time, blinky lights, stone generators. The idea is to not be so blasted serious here. Timing is everything. You've got to find a time when students are not committed up to their eyeballs already with coursework or other things. The students will tell you better than you'll ever know which weeks are bad weeks, which are stressful times. So I've always solicited input from my students on when would be a good way to do this. For the classes that tend to turn into chaos, it's nice to have some student help. Some of my students come back and help out every time I reoffer a course. They're there to help with the next generation. My other advice would be to expect complete total mayhem. A loosely organized course like this with 10 or 12 students, it gets pretty chaotic. Again, I've got examples here. Inexperienced programmers, no electronics background. I'm exhausted at the end of 2 hours of this. I'm bouncing around the room trying to look over somebody's shoulder and click, intercept, and say, this is exactly what you need to do. But that's okay. The students seem to enjoy that non-formal atmosphere, and it gets them loosened up, and in the best cases, within a half an hour, they're helping each other. And once one group has figured out how to do something, they're helping their neighbors and friends. As for you coping with the chaos, I would adjust your class size to suit your tolerance. It's if you can't deal with 27 people interrupting you, cut your class size down. It's also good to just throw up your hands and say, just try it. I don't know. You're trying to encourage students to explore on their own, and so that's fine. And it's hard as a teacher by profession to turn kids that loose. Obviously, that's not safe in a machine shop, but in other environments, it really helps to have kids just try things. Um, to to kind of wind up some of what I've found here, I'd like to say, to quote the Field of Dreams, if you build it, they will come. I've offered only a few pop-ups, and now I have students sending requests. They want computer pop-ups, Linux dual boot systems, getting started with LaTeX, getting started with GNU-Plot. I'm trying to imagine how I could have 12 students all installing different Linux systems onto different laptops. Uh, that could get pretty crazy. But they need help with this kind of thing, and they want me to run these short courses because it will be a way for them to learn little snippets of technology that they want right away without a course in the subject. The students are requesting lots more hands-on things, more solder kits. They realize themselves that they ought to know how to do this and that they were having way more trouble than they should have. I have them clamoring at me for more metalworking training. They want welding, which is an admirable idea, but I don't know how to weld, so I can't help them with that. They want Raspberry Pi intros. And I think the saddest comment of all on the hands-on skills was a pair of students who came to me and just said, "Oh, just anything you can teach us." They know that they're not getting the kind of lab hands-on training that you need to do experimental physics, and they're having fun learning these things, and they want more opportunities. They also want more of the professional skills, more job information, more just repeats of the ones we're already doing. We've also had visiting speakers come in from industry, particularly recent alumni that are young and out there doing the kinds of jobs that our students are apt to get in the next 5 years. And they really enjoy those, and they want more times to meet with those students and connect with people that are in industrial or entrepreneurship ventures with a bachelor's in physics. I now have faculty buying into this. I've got faculty requesting to teach pop-ups on assorted skills, cryogenics, some Astro software. I had one young faculty member offer a 3 or 4 day long short course over our intersession on X-ray diffraction, which was well attended. So to summarize, really, what are pop-ups? Anything. I why do them? Because it's a fun way to try things out that you otherwise might not have had a chance. Realistically, it's just a cool name. It lets you do a short course and give it an appealing name that makes it seem a little more organized than maybe it really is. So how, when, and where, whatever works for where you are and what your school is. There are some issues moving forward. Institutional backing, I think, remains the biggest bugaboo. Realistically, a pop-up does not generate tuition revenue, and yet it uses faculty time and resources. And at some point, I'm not sure that's going to fly on any sort of large scale. My feeling so far has been better to ask forgiveness than permission and just start and get some things going, and we'll worry about this later. A long-term goal of myself and others is to figure out some way, badging or accreditation, so that students would ultimately get some kind of formal credit for, if you complete 8 units of pop-ups on these subjects, you get the equivalent of an upper-level lab course or something like that. That would work bidirectionally in that it would help the students get credit for their learning, and it would help possibly with faculty get credit for their teaching. I would also say, as an issue moving forward, be careful what you wish for. This thing has ballooned into a lot of requests very quickly for me, and I now wish I had a lot more time to develop a lot of things, and I know what I'll be doing next summer. But it's great to see something that instead of getting pushback or lack of interest, I have students and faculty all trying to jump on the bandwagon. So, in summary, I'd like to thank the RIT School of Physics and Astronomy, the RIT College of Science, Crystal Bailey at the APS, and point out that the Pipeline Project is funded by NSF IUs under grant number shown here. Thank you.
All right. Well, Linda, gosh, thank you for an absolutely wonderful presentation. I've really enjoyed listening to you. So yeah, we do have a lot of really good questions coming in, so we'll get started. And for those, out there in the audience, now is the time. If you want to, submit your question, please do that now, and we'll try to get to as many of them as we can by the end of the broadcast. Well, the first thing I want to share is not so much it's a question / suggestion. One of our listeners has wondered, have you, with the mock interviews with the faculty members, well, first of all, I have a question, and then I'll follow up with this suggestion. How did you recruit the faculty participants for that?
Well, I started by doing one myself, and since I had 10 years in industry and a materials background, I culled some jobs from monster.com and stuff like that were materials characterization related jobs, or things where I thought I could fake it as a corporate representative from this job, because it was close enough to my training and my background that I could do so. These worked out so well that I had other faculty say, hey, I could do that. So I had an astro person who was willing to help with students who want to do data science jobs, because they had a lot of experience with, managing big data sets and the kind of computational resources you might need. So, you don't have to be an expert at the particular field. It's just nice to know enough to be able to ask a few leading questions of the student, and then have some sort of standard interview questions, the ones that undergraduates really fumble with, like, where do you see yourself in 5 years in your career, and what's your vision of an ideal job, and the standard interview questions that are not technically specific. It helps to put students through some of those.
Okay. And then related to that, getting onto the suggestion, because I think that would be one thing that faculty listening to this might wonder is, well, how do we do that job convincingly as faculty members if none of us, for example, have ever been in industry and don't have that insight? And so the suggestion was, have you considered asking alumni who are in industry to actually do those mock interviews by video conference or on the phone? Is that a thought?
That's an absolutely wonderful idea. Video or Skype interviews with alumni. That's a great idea, and I'm already scribbling notes to myself because I know alumni that might be willing to do so. It's less of a problem here at RIT because there's a couple of us who had some years in industry, and realistically RIT is in Rochester, where there's a plethora of ex-Kodak and ex-Xerox professionals that are now involved in the academic side. So I know quite a few people that have been around in industry long enough to know how to do this kind of thing, but not all universities have that. So tapping your alumni is great, and young alumni that are recent graduates are the best for this because they can really relate to the students.
Great, cool. All right, so moving on to the next question. So, you talked a little bit about how you kind of got together the resources to do these sorts of things, but generally speaking, how do you really kind of procure all the things that you need to do these kinds of pop-up classes? Like if somebody had a new idea and maybe they didn't have Arduinos in the department, or they didn't have a particular piece of equipment, how did you marshal the resources? And a related question, if you're a faculty member and you yourself don't really know about things like Arduinos and Raspberry Pi, how would you learn yourself about how these things work?
For the Arduino class, I happened to own one, and a research lab that I work in happened to own one. So I had two. And I was willing to just front the money to buy four more. And then somewhere downstream from there, I said, this is ridiculous. And I went to my department head and said, look, I'm willing to do all the legwork here, but I need a couple $100, really. And I was happily surprised. He was very supportive. I wasn't asking for $4,000. I was asking for, I think I asked for $250, and I came in at around $280, and he forgave me my overage. The little Christmas tree kits, I just bought them on my personal MasterCard mailed to my address, and then I asked, and I got a discount because I've done business with a company, and I was buying a bunch of them. And then I asked the kids to just pony up. It's $8 a piece. You want to do this? Fine. Give me your $8. Again, I probably broke 106 university rules by hand personal funding, and whatever. We'll sort it out next time I do it. But I think try to keep it on low budget initially, and then if the thing's a success, it's hard for a department to say, oh, you can't do that. Obviously, if it's going to be something that is going to cost lots of money, I would need more departmental buy-in. We have a new atomic force microscope with magnetic force tips, but the tips are really expensive. I'd love to do a short course in using MFM and AFM, but students start smashing tips. This is going to be ka-ching, 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 thousands of dollars, and yeah. I think that better be in a credit-bearing course rather than a pop-up just for fun.
Mm-hmm. Are there any other sorts of, besides, if you were to describe the specific ways that your background in industry helps you to do these kinds of classes, what do you think those would be?
I don't know if this is really my background in industry, because that was quite a long time ago, other than just my firm belief that the physics curricula doesn't get kids using their hands to do open-ended things in laboratories early enough, often enough, etc. And I think over the course of the last generation or generation and a half, students have less and less of those skills from hobbies. People don't work on cars anymore. People don't rebuild lawnmowers. People don't know, basic electronics and stuff that people in the 60s and 70s did at home for fun. Students nowadays, they don't have any of that experience. So anything you can do to get them working with their hands, and particularly if it's not a very formal curriculum, but a loose kind of thing where they get to just fool with it some, I think it's very useful for them. And if nothing else, it increases their confidence to just try, which, by the way, goes back to a previous question. What do you do about an Arduino class if you don't know anything about an Arduino? Buy an Arduino. I'll send you some notes. I'm just, I don't know anything. I sat down and said, They teach Arduinos in 7th grade tech class, for Pete's sake. I mean, surely a bunch of physicists can figure it out.
Right.
And I think we underestimate the students' unfamiliarity with this kind of thing. One of my favorite stories is I had a student in a machine shop, and we were doing some project where I needed some plates with fairly carefully spaced holes, and I was doing the intelligent work. I was doing the layout and the scoring of the plate and the center punch to get the hole in the right place. And I stood this kid in front of the drill press and said, you drill a hole. I handed him the right drill bit. He's standing
Yeah.
there. Eventually I realized he had no idea where the drill key, chuck key was or how to put it in. So I showed him, here's the chuck key, put it in this way. Here's how you turn it on. This is the right speed. And I went back to my markup, and he's still standing there looking at the drill like, And then he put the drill bit in and out about 6 times, and he turns to me and says, "Look at this thing. This is so awesome. It tightens on the drill bit on all 3 sides at the same time." And I just went, oh my goodness, this young man has never used a drill of any sort, ever. So,
Yep.
anything we can do to get students over that kind of hump, I think, is tremendously to the good.
Right, right, absolutely. Because I think it's an important point to be made that, pipeline, definitely the pipeline project is very focused on preparing students for what will actually be their future careers, which, for the vast majority, it will be in industry as an entrepreneur, as an innovator, as a scientist, as doing research, all of that good stuff. But guess what? These skills will make them better experimental physicists and grad students and experimentalists. I mean, we can all get behind that these are important skills.
Realistically, the teeny little bit of C they learned from me programming in Arduino at baby food level 1 blinky light they're not going to go get a job as a C programmer based on that. They're not going to have done enough with a microprocessor and visualizing other applications. And the teeny little bit they learned from me on Arduinos, they're coming back to me with, hey, can I use this to design a controller stage in my capstone? And could I maybe do this? And could I put a stepper motor onto this and then do that? And I'm like, yeah, sounds good to me. I don't know. I've never done it. Give it a try. I think they're good at making that extrapolation if you just kind of nudge them out of the shallow end a little bit so that they have to swim. They can figure it out from there on.
Exactly. So another question. It seems that you have been fortunate to have a lot of support at RIT, or have you? That's the question. Was there any instance where there was significant pushback or resistance to this idea? And if so, how did you kind of address that?
I did an end run on most of it in that I just started. And it was after hours. I mean, how many people in a department are aware of what you're doing in some otherwise unused lab at 4 o'clock on a Friday afternoon? And then the next thing anybody knew was the students were buzzing about how cool this was and what fun they were having, and it's hard to put the cat back in the bag then. I was totally serious about my better to ask forgiveness than permission. I just start. And if the students buy in, the students will make it okay. I did get some very definite pushback on the soldering projects from our technician because he believes to switching to lead-free solder, and he had a cow when he heard I was going to have dirty real solder with lead in it in the room, and we had quite a go-round. And I basically just put my foot down on that one and said, no, leaded solder is not against the law, and this is what we're using, and I'm following the OSHA guidelines, the EPA guidelines, the RIT Safety Department guidelines, and I will clean up afterwards and get over it. So I did get some pushback on that one, but you have to be careful whose toes you're stepping on what, but basically, to my surprise, everybody's been very supportive.
That's good.
I
Um,
think they're much more supportive than if I took, since I coordinate and teach AdLab, if I told the faculty that I was going to spend 3 weeks out of our semester in AdLab teaching machine shop and solder and electronics assembly skills, I would have a meltdown on my hands because you can't give credit for those things. That's not physics.
mhm.
But if I'm doing it
Yeah,
as a pop-up,
right,
that
right,
argument just dies.
right, right. I could definitely see that disconnect. Um, yes. So, I mean, clearly a fair amount of your time has to sort of go towards this because, as you said, it is not part of your official teaching load. Um, so how do you carve out extra time for this? We know that faculty are at spread as thin as can be a lot of times. So how did you find time to do these extra sort of courses?
Well, I've done the Arduinos because I really wanted to learn about Arduinos. They're selfish. How about that? Um, I did the silly little kits because I think they're cute and fun, and I don't care. That doesn't take any prep time for me other than the pushback to find enough soldering irons and get permission to use them. Um, the machine shop stuff is ending up being quite a time sink because I was never a high school shop teacher, and so I'm having a little trouble coming up with kind of prototype. It would, you need to build this object in order to pass, drill press one. I, I'm still working on a good way to get some kind of endpoint for that so that students know what they're getting into when they come down to work the first time in a shop. As to how I found time, I don't know. I stole it out of personal time, basically.
Hmm. Okay.
That's not a very
And
satisfying answer, I realize.
well, yeah, it's not surprising, I suppose. Um, and also, where did you first learn about how to do pop-up classes yourself? When did this idea first kind of dawn on you, and how did you learn? How did you learn, kind of how to get started on that?
I went to the VentureWell Open Conference last year, and the Open Conference is all about entrepreneurship and innovation. And I attended a session on PopUp Classes because I thought the name sounded cool. And the first speaker was a woman from Texas A&M, and when she showed me the list of things they do at Texas A&M, I just went, "Whoo, we got to start this right now." I thought it was awesome, and that was what really kicked me off, and I just can't wait to have more time to develop more of them.
And just to add to that, in case folks are curious what VentureWell and Open are, as Linda said, VentureWell is an organization that actually has been working with engineers and other STEM disciplines and is doing a lot of interdisciplinary work with artists, business students, and all kinds of different folks on how to foster more innovation and entrepreneurship education. And one of the goals of Pipeline, our project, is to see the community of practitioners, of physicists who are interested in teaching I&E, innovation and entrepreneurship. So we've been trying to send, more and more physicists to the Open Conference, which is VentureWell's yearly conference, where everybody shares, ideas about what has worked well for them, what hasn't worked well, and build these kind of connections across disciplines. So last year, Linda and several other physics educators went and learned some great stuff. We're hoping to have a larger convening of physicists at Open this year. So if any of you are interested, I would highly encourage you to check out their website, venturewell.org, for more
Regis-
information.
Registration is
Yes.
open now. I would also point out there's a nationwide push for maker spaces. And that's great, but I kind of have this personal view of I want to create like a physicist makerspace, which is not just a makerspace, but a place that physicists could go and tinker around with physics stuff, I mean, makerspaces don't typically have vacuum equipment and cryogenic equipment and pumps and stuff like that, but any kind of an area where students could go and fool with instrumentation and equipment design and apparatus improvements and stuff like that. And so I've got this vision of this makerspace kind of thing, which is similar to what the innovation and entrepreneurship people are pushing in engineering and other programs, but with a physics twist. And a lot of what the makerspaces do for certification that you are competent to use the loom or the mill or whatever equipment are little short courses that are very similar to pop-ups. So I'm kind of integrating ideas from makerspace training and what I learned at Open Conference about pop-ups.
Yeah, yeah, absolutely. I think that makes a lot of sense to kind of give them more of a physics flavor, or at least include technology that would be likely to be encountered by a student in physics research, for sure.
Mm-hmm.
And I have another question. So is there a place that you would be willing to share what you have developed at RIT in your pop-up classes?
Sure, I'm willing to share. I don't know what venue would be good. I think
Well,
actually at the AAPT conference next summer, I'm giving a talk, I think, on pop-ups. I don't remember. I think I got drafted. I know I got drafted for a talk. I think it was on pop-ups.
okay.
But as to curricular materials and stuff like that, let me think about it. I'm perfectly willing to share stuff. You want anybody that's interested in, say, the Arduino handouts, write me. I'll send them to you. But I don't know if there's some central repository. I haven't thought that far ahead. Again, this is all seat
Well,
of the pants from me.
right, and I should add that one of the goals of Pipeline, our project, is to actually create a repository of
Right.
materials, not just specifically what was developed by Linda at RIT, but also all of the different partner institutions that are all exploring different approaches to teaching innovation and entrepreneurship. I think we got time for one more question that just kind of came in. Someone is asking about a pop-up around quantum mechanics, and this person gives a link. I don't know what would be the best way to see that. Yeah, I don't know. I can't send that to you, Linda. I can't see what that link would be. Have you thought about doing pop-ups on more kind of fundamental physics problems?
Yes, I have, and certainly my colleague that did the short course on X-ray diffraction, that was straight up experimental physics, for material science and upper level solid state physics students. I, with my lifetime of magnetic materials, have thought of doing a short course rather than, but I would call it a pop-up now because pop-ups have become a thing in the department. If I say I'm going to offer a lecture series, nobody will come. If I say I'm doing a three-hour pop-up on magnetic material, practical and theoretical considerations, people will show up. I've thought of some more academic style things like that, but my first way to get this off the ground was to try the fun hands-on things and the professional development things, because those were the things that I thought students really had the most glaring need for.
I see. Well, okay, great. Well, that brings us to the end of our presentation time. We apologize if we didn't get to your question. We encourage you to follow up. You can certainly follow up by sending an email to webinars@aps.org, and we can either answer that or forward your question to the speaker for comments. As we mentioned at the beginning of the broadcast, a recording of the video and slides of the presentation will be made available on the webinar homepage. And you will also, as registrants, receive an email with a link to the recorded video of the presentation. We just ask that you allow 24 hours for us to get that uploaded and ready to go out to you. And lastly, in order to help us continue to develop quality webinar presentations, please take a moment to complete the short survey as you exit the webinar today. This wraps up today's event. We hope you'll join us again next time. American Physical Society, copyright 2017, all rights reserved. Bye-bye.